All right, so we've got yet another rational function here, right? And we are going to look first at the domain. And we're going to look at this and say, you know, I'm pretty sure I can factor out a 2. I got x to the 4th minus 16. We recognize that as a difference of squares, x squared minus 4, x squared plus 4. And that means, of course, we can now factor x squared minus 4. That's another difference of squares, x minus 2, x plus 2, x squared plus 4. We can't factor that anymore. And I'm pretty willing to bet that 2 and negative 2 are not roots in the numerator. So we're just going to leave that. We're going to say, okay, great, I have to throw out negative 2 and positive 2 from my domain. Those are going to be vertical asymptotes. And we're going to, again, mess with our scale here. So 2, there's one vertical asymptote, and negative 2. Okay, so what's our y-intercept? Well, that's easy enough. We're going to plug in 0. So f of 0, we've got 0 to the 4th plus 0 minus 2 over 0 to the 4th minus 32. So we're looking at 1/16. So just a little over the x-axis there. Do we have vertical asymptotes? Yes, we have x equals 2 and x equals negative 2. And, excuse me, we also know that we have a horizontal asymptote here, right? We want to look because we see that the degree, if both the numerator and the denominator are the same. So we are going to look at the ratio of those leading coefficients. And that is going to mean that our horizontal asymptote, sorry, it's going the wrong way, horizontal asymptote, y equals 8 over 2, otherwise known as 4. So we're going to draw our asymptote in here. Okay. So I don't know what the zeros are for this. It's a little bit hard to figure out there, but we know it can't go up, right? Because it's not, well, actually, we don't know that. You would probably want to throw in a couple of points, plot a couple of points. We're going to take the easy way out because I don't want to spend a lot of time doing that. We're going to graph it. So we've got, what, 8x to the 4th plus x minus 2. And zoom to fit. All right. It's never a good one, right? Oops. All right. Let's move this. And, oops, no, I want to do this. There we go. All right, so we do know that we have some zeros in the numerator somewhere, oops, cancel, somewhere, whatever these points are here. They don't look like pretty points. No, not pretty points. But okay, so I'm going to put that as my numerator. Then we've got 2x to the 4th minus 32. So we do know that we have those two zeros here. These are going to be exactly the same points. And we have probably that's a local max. There's our y-intercept. And you can see here that we do have, let's see, we said it was y equals 4. There's our horizontal asymptote. If we zoom way, way, way out, we can see that our graph just gets really, really close to 4, and that's it. Right, as we go positive infinity or negative infinity, that's where we're at. So we can go kind of finish our sketch here from maybe, here we are, from before. We can say, you know, roughly speaking, we're like this and like this. And then on the other side, we had something going on like here and like here, right? And it might cross, but probably not. You can actually find that out by setting your function, setting your numerator equal to the horizontal asymptote and then solving for zeros there. But we could say, hey, what's f of 3? And then we could say, okay, great, that's 8 times 81 plus 3 minus 2 over 2 times 81 minus 32. And that's going to be a positive number. So we know that it is positive, right, up here, probably. And we can do the same thing with negative 3. We can say f of negative 3. We're going to have 8 times 81 minus 3 minus 2 over 2 times 81 minus 32. So it's a pretty big number, positive, I think. But that's all I really care about at this stage. Okay. So we'll talk a little bit more about our horizontal asymptotes and then obliques.